These are the two equations. This one is a linear equation, while this is a quadratic equation, simply because the highest power of your x here is 2 and the highest power of your x here is 1. So automatically this equation 2, let's call this equation 1 and call this equation 2. Equation 2 is simpler to equation 1. So we can consider equation 2 in preference to equation 1. But there is a particular clause here. If you look at that equation 1 critically, it will be noticed that x is common to these two terms. So you can bring x out. So by bringing x out of this, you are left with 3x. And by bringing x out of this, you are left with minus y equal to 0. And when you have an equation like this, it means that your x can be equal to 0, or 3x minus y is equal to 0. And by so doing, x equals to 0 here, then your y is equal to 3x. Then, since x is equal to 0, I can put x, the value of x equals to 0 into equation 2 to get my y. From equation 2, which is 2y minus 5x equals to 1. When x is 0, then I will have 2y. 0 times minus 5, 0, equals to 1. Then my y becomes half. That means at that point, when x is equal to 0, my y is 1 over 2. That's the first critical value. Then, at this point, you have the equation 2. When my y, at this point, you can determine another value for my y. And you remember, it should be noted that your y is equal to 3x. Automatically, by looking at it from this angle, you discover that you have 2y minus 5x equals to 1. And since my y is 3x, so it will be 2 into 3x minus 5x equals to 1. I'm using the second equation now. So this y is 3x from here. So I substitute the value of 3x to represent y here. Then here, this one becomes 2 times this, that's 6x minus 5x equals to 1. Sorry, equals to 1. Then this minus this, that's x, equals to 1. So my x is 1. And when my x is 1, what is now the value of my y? From here, y equals 3x. When my x is 1, definitely my y will be 3. So we have the second point, 1, 3. So these are the two. So when x is 0, y is half. When x is 1, y is 3. So that is two critical points. Gradient of a curve. Another name for gradient is slope. Gradient is also known as the slope. For an equation like yx, that's the equation of a straight line, which is y equals to mx plus c, where m is the gradient that we talk about, gradient, and c is the intercept. We have two intercepts. We have the y-intercept. That is the region where the value of your x is 0. And we also have x-intercept. That is where the value of your y is 0. So this is the equation of a straight line. Let's see some examples to justify our claim. Example 1. Find the gradient of the lines joining A, we have A into minus 1, 2, and B, which is 3, minus 2. B, we have C, 0, minus 1, and D, 4,1. First and foremost, we must understand what the gradient is. When you have a graph such as what you have on the board, a representation where this is your x-axis and this is your y-axis. When you have a straight line this way, you have something of this nature where this is your N. Let's say this is your B and this is your A. This one automatically is a positive gradient. This is a positive gradient simply because as your x increases, as x increases, your y also what? Increases. So it will definitely be a positive gradient because x is directly proportional to y. So that means as x increases, y also increases. And you know that our gradient, which is denoted by n, can be delta y over delta x, or change in y over change in x, which can be simplified further as y2 minus y1 over x2 minus x1. So at this point, with respect to this graph, this is definitely logical reasoning is the next topic. In logical reasoning, it really tests the ability of somebody or someone to use his IQ to the best of its ability. And there are some terminologies that are very important in this topic. The first thing we talk about is the negation. What is negation? Negation is a simple closed statement such as S1 below may be true or false. Typical example, you have S1. S1 here states that Roslyn is a doctor. Roslyn is a doctor. The negation to this X1, which is S2, will definitely be Roslyn is not a doctor. So that is the negation to the S1 case. So here we base our analogy on the terms of dominance, which are true and false. Then the next one we talk about is the implication, Converse, equivalence. We often use Venn diagrams and sets of language to represent compound statements. A typical example is shown in figure 1.2. In figure 1.2, we have this symbol, which some call universal symbol, and sometimes it could be denoted by using mil. But here it is denoted like this. And the statement here says that those who live in Africa, while N here, those who live in Nigeria. F, people who live in FCT. If you look at these three statements, we will discover that the one that occupies the list is the F, those who live in FCT, which is smaller than those who live in Nigeria, because those who live in Nigeria serve as umbrella for this, while those who live in Africa serve as umbrella for those who live in Nigeria. So automatically this is the biggest, followed by this, then this. So if you want to represent it using a Venn diagram, it is very simple. By the concept of logical reasoning, we can represent this in a Venn diagram, and simply it is going to be represented as this, where this is the universal. So we have, let's say this is the FCT, F. Then we have this one is really embedded in it, or you can put it like this, just like a space, F. Then this one like a space. Then you have your N, followed by this. So here we see that F is a subset of N. We also know that N is a subset of the universal. And this one, this is an implied symbol in logical reasoning, which means that F is also contained in N. That means F is an element of N, or F is contained in N. And here also, we can also say that N is contained in the universal set. And since F is a subset of N, and N